Hello pre-cal folks, hope you're enjoying your day off, but we're going to do math anyway. We're going to learn today about angles in standard position. We've been working so far with angles that lie in a right triangle, so keeping things pretty simple. But as we branch on out into other applications, we need to look at angles that are bigger or smaller than what will fit in a right triangle. Feel free to take notes if you want. You don't really need to. I'll hand you a PowerPoint when you get back, so if you just want to watch, that's fine. If you want to draw some pictures, that's fine. And at least it's a video, you can pause if I'm going to quickly. You can go back and look at it again if you need to later when you're doing some practice problems. So, in standard position, we place angles in the coordinate plane. Everything ultimately goes back to the coordinate plane, goes back to the XY axis, and we put the vertex of the angle, or the point around which we rotate the angle, at the origin, and we always start our initial ray, our initial side, our starting side of the angle, on the positive part of the x-axis. That's just traditionally where we put it, so we think of that as 0 degrees. We've rotated no degrees in either direction. Now, in standard position, we rotate angles either counterclockwise or clockwise. If we rotate clockwise, we say that we've done a negative angle or negative rotation. If we rotate counterclockwise, that's a positive rotation. So if I rotate an angle 60 degrees counterclockwise, then I would label that a 60-degree angle that's positive. That ending side, where that ray landed, we refer to that as the terminal side of the angle. It terminates or stops there. If I rotate in the other direction, let's say I go clockwise 80 degrees, then I would label that, drawing the terminal side, I would label that negative 80 degrees. So clockwise negative, counterclockwise positive. It may seem backwards to us, but that's just the way we do things. Okay, I could also talk about radian measures. So let's say that I want to draw in standard position a pi over 6 radian measure. So I still start with the rotating point, or the point of rotation, the center of rotation at the origin, and the initial side is on the positive part of the x-axis, so that's 0 radians, because 0 degrees and 0 radians are in the same place, no rotation at all. And when I rotate around pi over 6, I could do it one of two ways. One is better than the other. I could just know that pi over 6 is 30 degrees and estimate where 30 degrees is. It's going to be better in the long run if I think of it as a piece of pi. This is 1/6 of a pi. Pi is a rotation halfway around a circle. And what I really want to begin to imagine is that I can divide half of a circle up into 6 pieces. That may seem overkill, but the denominators aren't always going to be special angles that we have memorized. So if I think about dividing half a circle up into sixths, whatever that denominator is, 1, 2, 3, 4, 5, 6 sixths of a pi takes me halfway around the circle, then 1/6 of a pi takes me one of those pieces. So that is a positive pi over 6. If I want to graph negative pi over 4, negative is a clockwise rotation, so if I go clockwise a half a circle, that's a whole pi. Denominator's 4, so I want to divide that half of a circle, that pi radians, up into 4 pieces, 1, 2, 3, 4, and I want to go 1/4 of those clockwise. So 1/4 takes me to here. There's my terminal side. Negative pi over 4 is that angle. Notice that I always put an arrow on it because it does matter which way you rotate. You can get by without drawing the initial arm, so that one on the x-axis doesn't have to actually be drawn in, but you definitely need to draw on your terminal side to show where the angle's rotation ended. Okay, couple more. Let's sketch an angle in standard position of negative 255 degrees. Negative is clockwise, and all I need to do is estimate. It doesn't have to be perfect. So I'm going to start on the positive part of the x-axis at 0 degrees. Notice I'm not bothering to draw on the initial side now. And there's 90, 180, 270 would be 3/4 of the way around. I'm not quite that far, so I'll stop before I get to 270, maybe about there, and then draw on your directional arrow. Make sure you draw in your terminal side. Label the angle next to that arc. So negative 255 degrees label goes here. Let's throw in a couple more. What if I want to sketch positive 7 pi radians? Okay, start at 0, positive part of the x-axis. Pi is half of a circle, so I need to go 7 pi's, 7 half circles. So let's go 7 half circles. There's 1, 2, I'm going counterclockwise because it's positive, 3, 4, 5, 6, 7. So the terminal side actually lands on the negative part of the x-axis. There it is. And we're going to label this 7 pi radians. So obviously we can go bigger than 360. We can go bigger than 2 pi. You can make as many revolutions around as you need to. And these sorts of thoughts are what we're going to consider when we do problems like how many times does the tire rotate in some sort of application problems. We can always go more than one time around. Let's do a couple with some weird denominators. I think we're going to be okay on the degrees. You guys can estimate degrees pretty well. Radians are a little bit tougher though. So let's do something a little more challenging, like how about 5 pi over 6? It's positive. We want to go counterclockwise. So picture half a circle is a pi. Divide it into 6 pieces. 1, 2, 3, 4, 5, 6 pieces. So starting at 0, positive part of the x-axis, I want to go 5/6 of the way around. So 1/6 of a pi, 2/6, 3/6, 4/6, 5/6 takes me to there. Draw on the terminal side. That's 5 pi over 6. You really don't want to whittle away time changing that to degrees first, because once you get to calculus, you won't use degrees anymore. You won't really even think about them. So everything is going to end up being done in terms of radian measures. So it's better if you think in terms of pieces of pi from the very beginning. Okay, what if we want negative 3 pi over 8? Can't see that negative very well. So negative is clockwise. So this time I'm going to go around clockwise, but I need to chop that pi, that half circle, into 8 pieces. So let's see. 1, 2, 3, 4, 5, 6, 7. You can pretend those are beautiful. And we want to go 3 of those eighths. So 1/8, 2/8, 3/8 takes me to about there. Draw on the terminal side. That's negative 3 pi over 8. And you don't have to draw on these dotted lines. If you can just sort of picture where they are, that's your best case scenario. But if you need to sketch them in, go ahead and do it. Alright, let's do a couple more real quickly, and then we'll go on to something called a reference angle. So what if we need to sketch in standard position 11 pi over 12? Okay, so let's get some coordinate plane drawn. It's positive. I'm going to go counterclockwise, starting at 0. And I need to divide half a circle into 12ths. Okay, so that means I got 6 pieces here. 1, 2, 3, 4, 5, 6 pieces, 6 pieces will make 12 pieces. Now, instead of drawing all of those in, I'm just going to picture in my mind what they look like. So 1/12 is one of these little pieces. So if I start at 0, a quarter way around the circle is 6/12. Halfway around the circle is 12/12, so I don't want to go quite that far. So I need to stop a little bit short of 12/12. 12/12 is a whole, so maybe about there. So that's approximately 11 pi over 12. All right, so angles in standard position, all you have to remember is to, if you're in degrees, just estimate 90 degrees in each quarter. If you're in radians, chop it into your denominator number of parts, each half circle denominator number of parts, and positive is counterclockwise and negative is clockwise. Okay, so last but not least, I've got about 4 minutes to get this clear, is something called a reference angle. And we need reference angles to do some trig when we come back. So a reference angle is defined as an acute angle between the terminal side of an angle in standard position and the x-axis. Okay, so first thing we know is it has to be smaller than 90. Second thing is it has to be between the terminal side, that's where an angle stops, and the x-axis. Okay, so what does that look like? Okay, let's take the angle 125 degrees. Positive means we go counterclockwise, so that's 90. A little more than 90 is 125, right? So somewhere in the neighborhood of there, we're going to estimate terminal side goes there, 125 degrees. Now, to find the reference angle, it has to be the angle between that terminal side, so where we just stopped, that side right there, and the x-axis. Now, the x-axis runs two directions. If I take the negative part of the x-axis, that makes an acute angle. If I try to use the positive part, that's an obtuse angle. I'm not allowed to use that one. It has to be acute. So it's got to be the closer distance to the x-axis. So what I've got to figure out is how big that angle right there is. So half a rotation is 180. I stopped after 125, so I really just need the difference between 180 and 125, which is 55 degrees. So that's the reference angle. In terms of notation, we'll often call the original angle in standard position theta, and then to distinguish between the two, we'll usually call the reference angle theta with a little mark on it. We read it theta prime. So theta itself is in standard position starting over here at 0, and then theta prime is that acute angle that's left over. Okay, 2 or 3 more. Let's find a reference angle for negative 140 degrees. All right, so negative is clockwise. Let's rotate 90, and 50 more makes 140. So there's negative 140. That's theta. And my phone keeps ringing. Sorry about that. And there's the terminal side. I want to know the angle between that terminal side I just drew and the x-axis that's closest to it. So this part here, that acute angle, how big is that? Well, half a revolution is 180. So we're 40 degrees away from a half a revolution there. So that's a 40-degree angle. So the reference angle theta prime is 40 degrees. If we do radian measures, let's find the reference angle for, let's say, 7 pi over 6 radians. It's positive. We're going to think in terms of 6 pieces of pi. So if I take half a circle, divide it into 6 pieces. All right, let's count. 1, 2, 3, 4, 5, 6, and I need a 7th piece right there. So there's my terminal side. So this is 7 pi over 6. Okay, so it's 6 sixths plus 1 more sixth. I want the angle between that terminal side and the x-axis. So that was an extra 1/6 of a pi past the halfway. So this is 1 pi over 6. So theta is 7 pi over 6. Theta prime is 1 pi over 6. We have time maybe for one more. Let's say I want a reference angle for negative 5 pi over 12. Okay, negative, I've got to go clockwise. Chop it into 12 pieces. Go 5 of them.